Unit 4, Lesson 9 on functions. So please write down the learning target, which is I can determine if a relation is a function by analyzing its inputs and outputs. Then try the do now, so pause the video, try the do now on your own. This is a review of Unit 4, Lesson 7 and 6, determining if an equation is a linear function. Pause it, give it a shot. Okay, so I hope that you paused the video and you tried this one. So remember, an equation is linear. There's three things that we have to check for. In order for an equation to be linear, these three things must be true. Okay, none of the variables are allowed to have an exponent attached to it. Okay, so let's check for that. Y does not have an exponent. X does not have an exponent. This one is good. Y does not have an exponent. X does not have an exponent. We are okay here. Y does not have an exponent. X does not have an exponent. That's okay. Y does not have an exponent. This X does have an exponent. Okay. So I already have my answer. The problem is that answer choice D, this variable has an exponent, so this is not linear. Okay. So that's already our answer. So remember the other things we checked for. X is not, or a variable is not allowed to be in the denominator of a fraction. Okay. If a variable is in the denominator, then it's nonlinear. Also, variables cannot be inside of square roots. If that happens, it's nonlinear. So go back, take a look at your notes for that lesson if you're confused. Okay, so functions. A function is a special type of relationship where each input has only one possible output. This is one of the most important definitions that you're going to learn in middle school and high school math. Functions are studied from now until you stop taking math classes. Okay. So we're going to take a look at a non-math example to try to understand what functions are. But again, a function is a special type of relationship where each input has only one possible output. Okay. So let's take a look at this vending machine example. And I'm hungry too, so talking about snacks is good. Okay, so we have a vending machine that has different snacks in it, and we're given this situation. So Genesis goes up to this vending machine first, and she presses the button C0. So she presses this button, C0. Okay, and these buttons are the inputs. Okay, I tell the machine what snack I want by pressing the button. So the button is the input that the vending machine gets. And the output that we get is the different snacks. When we talk about inputs and outputs, in this situation, the inputs are the buttons down here. C0, 1, and 2, 3. C0, C1, C2, and C3. And the outputs are the different snacks. Okay. Outputs. So Genesis goes to this vending machine and she presses C0. So I go to C0, and the first thing she gets out, she gets the first thing in the row, it's Cheetos. She got the first set of Cheetos, or the first bag of Cheetos, so I'm going to cross that out. So Enrique goes up next after Genesis. He presses C0 again. Well, he, of course, gets what's right behind that first bag, which is Cheetos. Now it's Tyrese's turn. So third, Tyrese goes to the vending machine. Tyrese chooses C2. He chooses a different button. He presses C2. He gets the first bag, which is regular Lay's. Good old yellow bag. Then lastly, our friend Brandon presses the C2 button after Tyrese. Didn't cross out. So Tyrese's Lay's regular bag is gone. Brandon presses C2. And he gets what's next in the row, which was the Lay's barbecue. Okay. So the question that's here says, based on the definition that's above, is this vending machine a function? Explain why or why not. So go back to this definition. The definition says each input has only one possible output. We said the inputs are the buttons that we pressed, and the outputs are the snacks. So the inputs are the buttons, the outputs are the snack. And each input is only allowed to have one possible outcome if this vending machine is a function. So pause this video if you need a second. Tell me if this is a function or not. Okay, so I hope you paused the video and you thought about this and tried this one on your own. But so this is not a function. Not a function. Because the input C2 has two has more than one output. Okay, more specifically, the C2 button has many different types of Lay's potato chips in it. Okay, you can press C2 and get regular, and then the next time you press C2, you get barbecue. The next time you press C2, you get sour cream and onion. Okay, in order for this vending machine to be a function, for every single button you press, you have to get the same thing every time. So C3, that's fine. Every time I press C3, I get Fritos. Every time I press C1, I get Munchies. Every time I press C0, I get Cheetos. But C2 is a problem because I get a different thing every time I touch it. Okay, so this vending machine is not a function because the input C2 has more than one possible output. Okay, all the different Lay's chips. Okay, so this is an example of a real life example of something that's not a function. Okay, we like functions in real life. Functions, right? When we do something like press a button, we want that button to do the same thing every time. We want it to be predictable. I want to know what it's going to do. So for an example, when I press a button on the elevator, if I press button number that says 5, I want to go to the 5th floor. If I press button number 7, I want it to go to the 7th floor every time.
Kimberly Venegas, if you're in the building, please report to the lobby immediately. Kimberly Venegas.
If I press button number 7 and it brings me to the 5th floor, the elevator's broken. It's not functioning. It's not working correctly, right? So let's take a look at some math examples of functions. Okay. So in a function, typically no x values are repeated. Okay, or an x value is repeated. But the y values, it is paired with r. The the same. Okay. Not a function. An x value is repeated and is not paired with the same y value every time. Okay, so we're going to talk about that in a second. So again, use the following sentences when explaining if a relation is a function or not. So when it says to explain, you're going to go here. Okay? And you're going to use one of these bullet points. You're either going to say a relation is a function when each input x has only one output y. Or this relation is not a function when the input x has more than one possible output y. So that's what you're going to say. And a little review from last lesson, the domain is all of the x values. The range is all of the y values. Okay, and if you forget which one's x and which one's y, okay, alphabetically, D comes before R. Alphabetically, X comes before Y. So put them in alphabetical order together and you'll have the right ones. Okay, so let's look at the first example. I want to know if this relation is a function. So I need to examine each input because our definition of a function says a function is a relation where each input has exactly one output. So I look at my inputs. My first input, right? The inputs are the x numbers. The outputs are the y numbers. Okay. We look at the inputs first. The first input is 4. Okay. Well, when I input 4, I can get an output of -2. But I can also input 4 and get an output of +2. Okay. So this relation is not a function. Not a function because the input has 2 possible outputs, -2 and 2. Okay, so again, since I found an input that has 2 outputs, this is automatically not a function. I don't have to look at 9 and 16. These would also fail the function test. But if any one of the inputs fails the function test, the entire thing's not a function. Okay. What we didn't write was the domain. I started with C. So the domain, remember, the domain was all of the x values. Okay. So the domain is 4, 9, 16. And the range was all of the y values. The y values were 2, -2, -3, 3, and -4, 4. Okay, so the order that you write the domain and range it does not matter. Okay, we're going to do 2 more examples, and then you guys are going to try the rest of these on your own. Again, pause if I'm moving too fast. Okay, so let's start with the domain. So the domain, all of the inputs, all the x's. Okay. So the domain is 2, 3, 3, and 4. Since the 3's are repeated, we don't write the number that's repeated. So the domain is just 2, 3, and 4. The range are the output y numbers. The range is 3, 4, 6, and 7. Three, 4, 6, and 7. 3, 4, 6, 7. Then this question asks if the relation is a function. Explain why or why not. So we need to look at all the inputs and we have to see if there are any inputs that are repeated. Okay, so I have 2 goes to 3. So this is the input of 2. I don't see any other inputs of 2. This ordered pair has an input of 3. So does this one. So these are repeated inputs. Okay, 4 is not repeated at all. Now every single input is only allowed to have one output if this is a function. Okay, this is not a function because when I put 3 in to the equation, I get 4 out. And when I put 3 into the equation another time, I get 6 out. So it has 2 possible outcomes. So 3 has 2 possible outcomes. Not a function. The input of 3 has 2 possible outcomes. Those outcomes are 4 and 6. Okay. Now we have our very, very last example. Okay. Example number 3. Whoop. What is the domain? Well, the domain is the set of all the x values. So this domain is just going to be the entire first column, 20, 19, 18, 17. The range is the entire second column, 1, 2, 3, 4. Now we want to know if this is a function. So when we look for functions, we look for inputs that are repeated. I have 20, 19, 18, 17. None of these numbers appears more than once. Okay, so this is a function. Function. Each input has only one output. Well, why do we say that? So you look for repeated inputs. Okay. Now, if none of the inputs are repeated, then it's not possible to have a different outcome. So think of the vending machine example. If I press the C1 button once, I'm going to get 1 snack out. I'm not going to press the C, if I press a button, I'm not going to get 2 different snacks out ever, right? So if I only press the button once, I'm only going to get 1 item. It doesn't matter what button I press. So it's impossible for me to get 2 items out and fail a function test. So if none of these numbers repeat, it's automatically a function because I didn't press the button twice. I can't have 2 possible outcomes. I can't have 2 different outcomes. If I only press the button once, the machine's only going to give me 1 snack. Okay? So this is a function. Each input has only 1 output. Right? 17 has 4, 18 has 3, 19 has 2, 20 has 1. That's the end of it for today. So please finish up the rest of this worksheet. If you were absent, show it to me when you have it done so I can give you credit for the classwork, and have a great day.